Hello, this is our final video of 1.5 and it will cover problems 69 through 72 and 89. And what I have, I'm doing number 71. And if you remember my last video, I said that some of these functions you may not even recognize. You won't know what the graph looks like. Some of you guys may not know what this graph is, and you probably wouldn't know unless you've had a trig class. This is actually a sine curve that's been already shifted over a little bit. So anyway, so this is a sine curve. Now you're like, oh, we're not in a trig class, I don't have to do this problem. Oh yes, you can. You can do this problem because all you're doing with it is going to be moving it left to right. So you may not know much about the actual function, but you know its shape. And then, so on this one right here, this is f of x right here, and I forgot to put it up there. But that's f of x, and what this is basically saying is you're going to add 3 to the f of x to get a new function, cap f of x. So that means you're going to add 3 to all the y coordinates. So you guessed it, it's a vertical shift. So it's taking this graph and moving it up 3 units. So this little shape here, little bells thing if you want to call them, will go up 3 units. So 1, 2, 3. So this negative pi 0 will go up to negative pi 3, and it will end up at pi 3 and 0, 3. And then this graph actually went in the middle, went down 1 unit from the middle. Or you can also think, well, that's got to go up 3 as well. So it does. If you go from negative 1 to 2, you are going up 3. And right here, this one's going from 1 to 4 because you have to go up 3. So it looks like this. So that's the shape. So the graph has been moved up 3 units. Now the next one is kind of a tricky one because it's f of x plus 2, which they're not really labeled really nice for you here as it is. It's negative pi to pi. So f of x plus 2 will actually move the whole graph to the left. So if you go to the left of pi 2 units, where are you at? See, it's kind of hard to figure that out. So what you're trying to do is just say, well, I got to go left of negative pi 2 units, so what is that number? I'm not going to try to do the calculation. I'm just going to go ahead and put the number on the graph. So here, you go from this point, this right here, this point, 2 units to the left, you're over here. So the whole graph gets shifted 2 units to the left. Now, I like to cheat a little bit. I like to just look at this graph right here and move the axis 2 units to the right. That would be the same thing as moving the graph 2 units to the left. And then rename everything. So that's kind of what you're doing. So this very last point out here is not going to be at pi. It's going to be pi take away 2. So this is where pi is at. If you take away 2, it's going to be right here. So that's your last point. And then that was at 0 is going to go out this way. So negative 2 is right there. It was at 0, remember? And over here is at negative pi, but you got to go left 2, so negative pi minus 2. And the good news is that it still hasn't changed its height. It's actually in this class, in this class, this is actually taught, it's called the amplitude. So then the shape is pretty much the same after that. So that's kind of what it looks like. So, but everything gets moved to the left. Now, remember I said, well, I like getting the graph. If you look at this graph and you kind of shove it 2 units to the right, it's kind of what you got. That's the shape that you're going to end up having. Because remember, here's pi over 2, so it's very close to that. So, but that one's kind of a tricky because the units are, skewed a little bit, and you're not used to working with pi's and pi over 2's and stuff like that. But just kind of keep in mind, everything gets moved 2 units to the left. If you want to kind of get an idea what those actual numbers is, and that's what a lot of people do because they don't see pi minus 2 as a number. It is. it's 3.14 minus 2, which is what, 1.14. So that number right there is 1.14. So that's the approximate location of that point. Okay, and the last one is f of negative x. Remember what f of negative x is? That is it's called a horizontal reflection. It reflects across the y-axis. So this top bell is a top bell over here, and this bottom bell is a bottom bell. So it just kind of flip-flops. It's a horizontal reflection. So it looks like this. The good news is it's still negative pi to pi it's in its boundaries, and it starts, middle, stops. So the bottom bell is up here now, because that was in the first quadrant before. Now it's in the second because guys it got reflected over, and the part that's over there in the third quadrant gets over here in the fourth quadrant. So it looks like that. So, and you might guess, well, what if it was negative f of x? Well, in this case, it's the same shape as this, but it'd be a little different because this part, if it's a vertical reflection, this bell goes up here and this bell goes down here. But since these have symmetry, it's the same thing. So this is one of those cases that f of negative x would actually give you the same shape as negative f of x. So you wouldn't notice the difference between the two graphs. Okay, so that's 71. And but this one here is, you don't need to know parent graph because I just showed you the parent graph. So that's the difference between this one and the last video. Is the other ones, they gave you an equation. You had to come up with a basic graph, and then based on that basic graph, apply a transformation to it that they ask you to. And this one, they give you the graph and they just tell you, okay, I want you to do a horizontal reflection. I want you to move it 2 units to the left. I want you to move it 3 units up. That's really what's going on. So, okay, and number 89 is one of our applications. And this is very wordy in the problem, and I did a lot of paraphrasing. They're comparing two temperature scales, Celsius and Fahrenheit, and a lot of you guys might recognize this formula. F equals 9/5 C plus 32. That's the formula that will convert Celsius into Fahrenheit. The next formula you may not recognize. It's K equals C plus 273. K is Kelvin. That's another temperature scale that you probably may have heard of, but you don't know much about it. But if you want to know what the degrees is in Kelvin, you have to add 273 degrees to the Celsius temperature, and that gives you Kelvin, and that'll give you Kelvin. Now, what we're trying to do is we're trying to convert Fahrenheit, basically Kelvin into Fahrenheit. So that's what they want you to do. If you read the problem, that's kind of what you're going on, and you want to do the graph of that. So if Kelvin equals C plus 273, then Celsius is Kelvin minus 273. It's just a flip-flop of the variables. So what I did was I put K minus 273 into that formula for C. So it's a substitution kind of a thing. So it comes out that F equals 9/5 C, where C is K minus 273. And if you look at this one compared to this one is going to be a horizontal shift, 273 units, that when you compare this up. So you take these 2 points and you move it over 273 units. So now, if you go 273 units this way, whoops, I know it's not drawing the scale, it's not my purpose. So I move this point 273, it would be right here. So that point gets moved 273 units. And then take this point and move it 273 units, and that's going to be, what is that going to be? 273 plus 5, 278. 278, 41, and connect the 2 points. And I'm not sure if that's above or below the origin, but not the best artist in the world. I'm pretty sure it's probably going to go below it. So because it's not even drawing the scale. So. But the thing is, that's kind of what's going on. You're taking this graph and you're moving it 273 units to the right. So if you want a more accurate comparison, probably you'd want to scale this a little better than I just did. Make the scaling a little better. But my point I wanted to make when I did this problem is I wanted to show you that if you're making a comparison between two temperature scales, and then one of those temperature scales is to another one, then the first and third one can be compared to each other based on that formula. So you just take that graph and move it 273 units because that's a horizontal shift of 273 units. And then you find the points that you know on the original graph and just move them 273 units to the right, which basically means just add 273 to your x coordinates, and then you got your other comparison. So that's kind of how it works. So, but anyway, that's all of 1.5. And there's 5 videos. Make sure you try, if you get confused on some of them, you might want to watch some of them again, because these are relatively short videos here, so in the big scheme of things. So, all right, thank you for watching.